So, what's coming out? nanodac, new firmware. The big thing we're going to hit on today is support for BACnet, a communications protocol that I'll go into a lot more, as well as some calculations, an application block when using steam and any processes using steam and energy calculations. BACnet, and certainly stop me in this part because I know this is new to a few of us. I've had a couple coffees this morning, so I might go a little faster than I'm intending. But what I'm going to try and do is give you guys a good overview of what it is and why we put it into the nanodac and what the future of BACnet looks like. So you may be familiar. BACnet, pretty much just another communications protocol that can be used to integrate other devices, instruments in a given application, control scheme, system. But just to give you a little bit of background, it is open, so much like Modbus is today. A couple other protocols out there are proprietary. We're thinking about Profinet and Ethernet IP. BACnet was built as, or more conceived as, an open protocol so that multiple vendors could be connecting to the same network under the same standards. So you'll see it does have an ISO standard attached to it, an ANSI/ASHRAE standard, and for those of you who are new to it, ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, they put on a large show every year in the January-February timeframe. We've gone for the last 4 years, I believe. A pretty big show, a lot of opportunity there as it relates to that, especially with BACnet. They're more so, I suppose, geared towards commercial applications, but as we move forward, the industrial, commercial, and consumer applications are starting, those lines are starting to become more blurred as things and devices become more connected. So the good thing about BACnet is that it works over existing physical layers. So what's a physical layer? Ethernet, your typical serial copper wire comms. There's some wireless communications, and so essentially that's the physical protocol layer of communications, but BACnet slides right on top. This diagram kind of gives you a better idea of how it might be used in a typical setup. So we're looking at from the top down. The top is where you're accessing it. The bottom area, or your all the way at the bottom of the screen, is the kind of extension of your devices, and so everything's connected, right? So in this example, the devices might be your mobile, say an iPad or your phone or something. The web server essentially connects everything, so maybe you're connecting over a VPN from a remote site, or just a typical setup like today, maybe even is a direct connection via a simple workstation. So that can be used as the plant manager's resources, or even just the operator. But you can kind of tell the only thing that's really changing here, if you're familiar with larger SCADA setups, is the type of things that are connected, right? So instead of a large setup of heat treating, for instance, or maybe some plastics that are connected, you've got an HVAC system, lighting, and a water management system, which might be typical in a large commercial area such as a hospital or university system, which is where we have found some early success with BACnet. And just to give you some examples, right, all these web servers, right, we're connecting the dots, need data centers, because essentially it's all coming down to the hardware that creates the cloud. So to bring it full circle, maybe you have a data closet cooling system, which is connected to the larger, broader HVAC system in scope, but that's also accessed from the BMS that now the nanodac can be integrated with. And even, let's say the nanodac was a Modbus master to a couple EPC 3000s, maybe it's a Mini 8, maybe it's a couple of other third-party devices, a couple of examples to bring and integrate everything together. So hopefully that makes sense. And again, it works over existing physical layers. So not much to change as far as the physicality, as long as we're using that protocol. And so as we move into the future, Eurotherm, of course, is part of Schneider Electric, which has a large commercial-facing business unit, the buildings industry. So if you ever see anything Schneider Electric buildings, I know some of you are affiliated with the larger Schneider Electric products in general, so there could be some cross-collaboration there. And that's the whole point of the next couple things that I want to talk about. So being able to add value without adding complexity, right? Everyone's probably familiar with setting up a gateway, whether it's to an Ethernet. Now, modern day, maybe you're setting up a 485 serial connection to try to interface with an Ethernet gateway. As more devices start to standardize on Ethernet, of course, you get that in the EPC 3000 series. That was one of the big selling points, is being able to integrate right off the gate into a 16th DIN unit with Ethernet in it. But as more people start to use Ethernet, it's becoming pretty much worldwide standard. And of course, there's this huge opportunity out there because that existing physical layer allows you to have devices that can speak many different protocols on those layers. So where is the opportunity? Another quick example here. So this is what a typical hospital system might look like. There are multiple layers of security when we start talking about hospitals, but I just kind of wanted to highlight, and I'm going to pull out the annotation tool here so we get a better idea. So hopefully you can see my laser pointer on the screen. Instead of this liquid oxygen tank, maybe it's like the boiler room, which is distributing heat and energy to a sterilization system, right? Everything has to be clean. Everything in a hospital generally has 3 different levels of sterile environments. So lots of tools used for that. Of course, all the HVAC stuff has to be monitored and connected together. And so with all that information, if it's on the same protocol, BACnet, it can be accessed from the same system, and therefore you can make better decisions, whether it's monitoring or controlling all these different applications and processes within the same system. And so that's what you'll hear a lot about when people mention smart buildings or smart cities, is having everything connected on the same type of network, whether it's different levels of security that you need to access those networks. BACnet adds another tool to be able to go and access these different networks. So today, very familiar with setting up a Modbus network, but now instead of having to set up a gateway, if you're trying to integrate with BACnet, it's an embedded protocol that's being used right from the get-go, so it's very easy. And so what happens along with that? I mentioned Steam a couple times in this. So the second thing we've added in the firmware is new application block. So much like the sterilization application block, carbon potential application block that we have in the nanodac and EPC 3000, amongst others. Essentially what we've done is built a similar one around steam flow and saturated steam flow, to be specific. So what does that let you do? A lot of integrators generally use another instrument or device to make these calculations. So you're adding cost, you're adding complexity, but you're also, if you're not using it today, it gives you a couple of extra tools in the nanodac so that you can actually start to make these calculations, start to calculate things like energy usage, boiler efficiency, and where you may be losing energy in your system. So it's kind of all about driving efficiencies. And so just from an educational standpoint, there is a technical bulletin that is extremely resourceful when trying to get some background info. So I highly recommend that to you as an introductory read if you're trying, or just a refresher, just to get a better idea of what these application blocks are doing. And so there are a couple of different outputs. Generally, you're looking to input a temperature and a pressure, and the reason is that when you're using saturated steam at a given temperature and pressure, they directly correlate. So they're always going to be, as in this table here, if you have saturated steam at a PSI of 1, that temperature of the steam is always going to be this temperature here. And there are some other external factors like dryness and things like that that might affect it a little bit, but for the most part, this table is kind of the standard upon which calculations are made and systems are built. And so the application blocks allow you to use these in order to calculate things like heat flow, mass flow, heat consumed, enthalpy, and putting those all together with some of the other math and logic function blocks in the nanodac, you can start to determine efficiencies like boiler efficiency. How much energy am I putting into the system versus how much am I actually getting out? So this can be a great tool to kind of show ROI for using a specific device, even if it's a mechanical fixture. So that's the type of stuff that consumers and end users are looking for, right? What is, if I pay this amount for this tool, i.e. the nanodac or whatever the case is that's interfacing with it, what's my return? Why is it better? And so you can start to show things like that, which can be really powerful to the end user. The other part of it is the mass flow, and again, the technical bulletin, it's actually Technical Bulletin 1056, one of our white papers that's available on the nanodac downloads page, which I highly recommend. Has a quick read, is very good at explaining the background and why you might use this. So that is essentially the new application block feature that goes hand in hand with the BACnet communications protocol implementation. So that's the big news for the new firmware version 8.10.